Okay, the screen is visible to all? Okay, in the last lecture, we see that what is the potential function. Okay, the last point, potential function. If g of x, y, z is equal to 0, then the function g is said to be potential function if g satisfies the Laplace equation. Okay, so this is the delta square g is equal to 0. Okay, and delta square of g is equal to dou 2g by dou x square plus dou 2g by dou y square plus dou 2g by dou z square. Okay, so moving towards the next point, the families of equipotential surface. Okay, so what is the definition of families of equipotential surface? Look, let small f of x, y, z is equal to c. Okay, be the one parameter family. Be one parameter family. One parameter family of surfaces. Be a family of one parameter family of surface. Okay. Why one parameter family? Because c is the only one constant is there. Okay, so let f of x, y, z is equal to c be a one parameter family of surface. We say that this family of surfaces is equipotential. Equipotential if there exists a potential function, psi. Okay, if there exists a potential function psi. Okay, what is the meaning of potential function? It satisfies the Laplace equation. Okay, that is right on the bracket. It is a function. It is a function which satisfies the Laplace equation. Okay, what is Laplace equation? Delta square of psi is equal to 0. Okay, so if there exists a potential function psi such that psi is constant, whenever small f. Okay, this small f is constant. This small f is constant. What is the meaning of this sentence? Okay, if let f of x, y, z equal to c be the one parameter family of surface, we say that this family of surfaces is equipotential. Okay, if there exists a function psi, potential function psi, such that psi is constant whenever f is constant. The meaning of this sentence is that it's okay. It means that there exists a functional relation. There exists a functional relation in between this small f and psi. That is, psi is equal to capital F of small f of x, y, z. Okay, whenever this psi is constant, okay, such that if this psi is constant, तो वहाँ पे असेल small f पण तुमचा constant असेल. Okay, या हेडिंग्स आधी लक्षात समजून घ्या. Families of equipotential surface. इन 3 डायमेन्शन स्पेस मध्ये समजा तुम्हाला एखादा सरफेस दिला असेल तर प्रत्येक पॉइंटला त्या सरफेसवरच्या प्रत्येक पॉइंटला तिथे काय असेल तुमचा पोटेन्शियल इक्वल असेल. ओके, 12th मध्ये पाहिला असेल इक्विपोटेन्शियल सरफेस इन 2D मध्ये पाहिला असेल. ओके, सो इथे काय तुमचं 3 डायमेन्शन स्पेसमध्ये प्रत्येक त्या सरफेसवरच्या प्रत्येक पॉइंटला तुमचा पोटेन्शियल काय असेल इक्वल असेल. ओके, युट्यूबवर भरपूर व्हिडिओ आहेत त्याचे इक्विपोटेन्शियल सरफेस टाईप केले लगेच असेल तुम्हाला. ओके, जर फिजिकल सिग्निफिकन्स वगैरे समजून जाईल तुम्हाला. ओके, इट मीन्स दॅट there exists a functional relation in between psi and small f, that is capital F, whenever this psi is constant and f is constant. Okay, so what is note is there, what is note, not every one parameter family of surface. Okay, that is small f of x, y, z is equal to c is family of equipotential surface. ओके, प्रत्येक वन पॅरामीटर फॅमिली जो असेल तो इक्विपोटेन्शियल सरफेस असेलच असं आपण सांगू शकत नाही. ओके, नॉट एव्हरी. If this satisfies this condition, if there exists a function psi whenever if psi is constant, whenever f is constant. जेव्हा जेव्हा हा तुमचा स्मॉल एफ कॉन्स्टंट असेल हा तुमचा psi पण कसा असायला पाहिजे कॉन्स्टंट, and this psi satisfies the Laplace equation. Okay, now one result is there. Look at the result. Find the condition that find the condition that the one parameter family of surface okay forms a family of equipotential surfaces. Okay, so we have to find here the condition that that surface, the family of surface forms a family of equipotential surface. Okay, now look at the solution of this one. We have to find the condition that the one parameter family is to be a equipotential surface. So what is the condition? Look at this, the solution. Let small f of x, y, z is equal to c. It will be a one parameter family. A one parameter family of surface. Okay, so by the definition f is okay, this f small f of x, y, z is equal to c is equipotential if by definition क्या है, if there exists a potential function psi, okay, such that psi is constant whenever f is constant, whenever small f is constant. Okay, so what is the meaning of this sentence? That is, it means that there exists a functional relation. Okay, there exists a functional relation in between psi and f. Okay, capital F of fxyz. Okay, जेव्हा जेव्हा तुमचा f of xyz is equal to constant असेल तेव्हा तुमचा psi ha constant Russell and psi ha cancel Laplace equation satisfy करें. Okay, give it as an equation number 1. So this is the definition of equipotential surface. Okay, now between psi and f, between psi and f, small f, okay, such that psi is constant whenever the small f is constant. Okay, now differentiate equation 1 with respect to x. We get differentiate equation 1, okay, with respect to x. What we get? Dou psi by dou x is equal to, okay, now this is the capital F. Differentiate capital F with respect to small f. Okay, function by the function, the composition function, composition of a function. So differentiate capital F with respect to small f into small f is the function of x. Okay. Again, differentiate with respect to x. Again, differentiate with respect to x. What we get then? Dou 2 psi by dou x square is equal to the u is the derivative of first dou 2f capital F upon dou small f square, okay, into f is the function of x, okay, आणि हा second as it is, म्हणजे हा काय झाला तुमचा square plus first derivative second as it is. Now first derivative second, आता second काय करतो, second derivative काय येईल ते first term as it is, capital dou f by dou f small f, okay, into derivative of this term with respect to x. What we get? Dou 2f by dou x square. Okay, give it an equation number 2. Similarly, we can write for y and z. Okay, similarly for dou 2 psi by dou y square, we write dou 2 capital F upon dou small f square into dou f by dou y bracket square plus dou f by dou small f into dou 2f by dou y square. Give it as an equation number 3rd. Similarly for z now, and dou 2 psi by dou z square is equal to dou 2 capital F upon dou f square small f into dou small f into dou z bracket square plus dou f by dou f small f into dou 2f by dou z square. Okay, so this is equation number 4. Okay, any doubt up here? Hello, any doubts I get them?
No, sir.
Okay, so we differentiate the psi with respect to x, y, z. Now we know that the psi is potential function. What is the meaning of potential function? It satisfies the Laplace equation. Okay, but psi is a potential function. Okay, psi is a potential function. So that is, it satisfies Laplace equation. Okay, that is delta scale of psi is equal to 0. Therefore, what is the value of this one? Dou 2 psi by dou x square square plus dou 2 psi by dou y square plus dou 2 psi by dou z square is equal to 0. Okay, now putting the values of dou 2 psi by dou x square plus dou 2 psi by dou y square plus dou 2 psi by dou z square. From equation 2, equation number 3, and equation number 4, we get putting the value of equation 2, 3, and 4 here. So we get dou 2 capital F by dou f square into bracket dou f by dou x bracket square plus dou f by dou f small f into dou 2 capital small f divided by dou x square, okay, plus dou 2 capital F upon dou f square into dou small f upon dou y bracket square plus dou capital F upon dou small f into dou 2f upon dou y square, okay, plus dou 2 capital F upon dou f square into dou f by dou y whole bracket square plus dou z, okay, in plus dou capital F upon dou small f into dou 2f by dou z square is equal to 0. Okay, now taking dou 2f by dou f square common from this first term. या first term काय common करायचं आपल्याला dou 2f capital F upon dou small f square. So this implies dou 2 capital F upon dou small f square into the first bracket हा term dou f by dou x bracket square plus second bracket common dou f by dou y bracket square plus dou f by dou z bracket square, okay, plus now taking dou f by dou f has term count करायचं, okay, now taking dou f by dou small f common. So this is dou capital F upon dou small f into bracket dou 2 capital F upon dou x square plus dou 2 capital F upon dou y square plus dou 2 capital F upon dou z square is equal to 0. Okay, any doubt up here?
No, sir.
Okay. Now this is the value of dou 2 capital F upon dou small f square. This is the value of gradient of f bracket square. Okay, plus dou capital F upon dou small f is into, this is the value of delta square f. Okay, so this is equal to 0. Okay, now this one is f double dash of f. This is the f double dash is the function of f into gradient of f square plus this is f dash of f, okay, into delta square of small f, small f is equal to 0. Now by rearranging the term we get capital F double dash of f divided by small f dash of f is equal to minus of delta square f divided by gradient of f square. Okay, give it as an equation number 5. Okay, any doubt? So this shows that the condition the surface f of x, y, z is equal to c forms an equipotential surface. Okay, forms a family of family of equipotential surface. Okay, so a family of equipotential surface is that the quantity, which one? This quantity. Okay, what is the quantity? That delta square f divided by grad f bracket square. Okay, is a function of small f alone. Okay, ही जी quantity है पूर्ण जी quantity. ये क्या है पहले? It is the function of f alone. Okay, so the quantity function of f जरिए से f of x y z is equal to c is form से equipotential surface. Okay, now we denote this function, this one. Okay, यह function अपन क्या denote करते हैं? Chi of f. We denote this function by the chi of small f. Okay, therefore the equation 5 becomes, okay, therefore the equation 5 becomes f double dash of f divided by capital F dash of f is equal to this minus sign as it is, and this is chi of f. Okay, now integrating with respect to f now, this equation. So integrating with respect to small f, we get this is log of capital F dash of small f is equal to minus of integration of chi of f into df. Okay, plus and log a is the integration constant. So this implies capital F dash of small f is equal to, okay, a into e raised to minus chi of small f into df. Okay, e raised to log a is a. Okay, now so this is the value of f dash of f. Now again integrating with respect to f now, this equation. Okay, हे कसा समजलं स्टेप? e raised to log a त्याला आपण a म्हटलं. ओके, हा इंटिग्रेशन कॉन्स्टंट आहे, ह्याला काय फरक आहे, इफेक्ट नाही होणार. ओके, एक्सपोनेंशियल फॉर्म मध्ये लिहिल्यानंतर हा असा येईल e raised to minus chi of e raised to minus integration chi of f df हा आला इथे, आणि e raised to log a कसा येईल is equal to a, that is integration constant, and this one is f dash of f. Okay, so again integrating with respect to f now. So again integrating the above equation with respect to small f. Okay, so we get this is now capital F of f is equal to integration of a into e raised to minus integration of chi of small f into df plus integration constant is p. But what is the f of f? F of f is nothing but first one, write this one, where a and b are constant. Okay, of integration, constant of integration. So this implies what is the value of f of f? Okay, psi is equal to capital F of f होता ना तुमचा. This is the value of psi is equal to integration of a into e raised to minus integration of chi of small f into df plus p. Okay, give it as equation number 6. So this is म्हणजे तुमचा तो हे जो होता इक्विपोटेन्शियल फंक्शन हा कसा असायला पाहिजे या फॉर्म मध्ये असायला पाहिजे where psi is equal to integration of a into e raised to minus integration of chi of f df plus b. Okay, so this shows that the general form of the corresponding potential function. ओके, म्हणजे एखादी नेसेसरी कंडिशन काय यायला पाहिजे जर एखादा वन पॅरामीटर फॅमिली ओके तर तुम्हाला एखादा वन पॅरामीटर फॅमिली दिलेला असेल आणि तो जर तुम्हाला म्हटलंय तो जर इक्विपोटेन्शियल सरफेस आहे फॅमिली ऑफ इक्विपोटेन्शियल सरफेस ओके मग त्याच्यामध्ये हा असा एक फंक्शन एक्झिस्ट होईल जो व्हेनेवर एफ इज कॉन्स्टंट साईज कॉन्स्टंट आणि त्या साईजचा फॉर्म कसा पाहिजे इन दिस फॉर्म integration a into e raised to minus integration chi of f df plus b. Okay, so this is the necessary condition for the one parameter family of surface f of x y z is equal to c is the family of equipotential surface. Okay, so this is म्हणजे एखादा जर फॅमिली वन पॅरामीटर फॅमिली जर तुम्हाला इक्विपोटेन्शियल सरफेस आहे तर असं म्हणत असेल तर तुमचा psi हा व्हॅल्यू हा येईल. ओके, so this is necessary condition that the one parameter family okay the one parameter family of surface small f of x y and z is equal to c is the family of equipotential surface. Okay, any doubt? पहा पुन्हा एकदा पहा आपल्याला काय फाइंड रिझल्ट काय होता फाइंड द कंडिशन दैट द वन पैरामीटर family of surface forms in family of equipotential surface. Okay, that is we have to find the necessary condition for a family of equipotential surface. Okay, let f of x y z be the one parameter family of surfaces. If it is the equipotential surface, it satisfies the Laplace equation. There exists a Laplace potential function psi which satisfies the phi is equal to f of f. That is, whenever f is constant, then psi is constant. Okay, from that Laplace equation, we determine this one. F double dash of f upon f dash of f is equal to this condition. ओके, हा तुमचा काय इकडे राईट हँड साइड पूर्ण तुमचा फंक्शन ऑफ स्मॉल एफ अलोन. ओके, म्हणजे हा काही तुमचा पूर्ण टोटल फंक्शन ऑफ एफ. Okay, so now we have to determine the value of psi. Okay, so from integrating 2 times we get the value of psi. Okay, so this shows that the general form of the corresponding potential function. Okay, एक एक्झाम्पल घेतलं की आपल्याला समजेल व्यवस्थित. ओके, थेरम मध्ये काय प्रॉब्लेम काय अडचण?
No, sir.
Okay, now look at the example now. Show that example number 1. Show that surfaces x square plus y square plus z square is equal to r square. Okay, sphere sorry. Equation, okay, where r greater than 0 radius form a family of equipotential surface and find the general form of corresponding potential function. Find the general form of corresponding potential function. ओके, रियल इक्वेशन काय तुमचं वन पॅरामीटर फॅमिली आहे का? येस. आर हा एक कॉन्स्टंट आहे. फॉर डिफरंट व्हॅल्यूज ऑफ आर वी गेट डिफरंट स्पियर्स. Okay, and that family forms a equipotential surface. We have to prove that one. Okay, and find the general form of corresponding potential function. Also, we have to find the value of psi. Okay, a proof. Let small f of x, y, z is equal to x square plus y square plus z square is equal to r square. Give it as an equation number 1. B, one parameter family, वन पॅरामीटर किंवा टू पॅरामीटर फॅमिली म्हटल्यानंतर तुम्हाला कॉन्स्टंट ए आणि बी असायला हवा असं नाही. ओके, सी असेल, आर असेल, काही असेल. ओके, नाही तर तुम्ही वन पॅरामीटर फॅमिली म्हटल्यानंतर तुम्ही ए बी आणि ए आणि बी शोधत बसतात. ओके, सो बी द वन पॅरामीटर फॅमिली ऑफ सरफेस. Okay, so we know the equation 1 form the family of equipotential. Okay, equipotential surface if look at it, this quantity, okay, this quantity है. This quantity forms a function of f alone. Okay, आता पाहिजे function of f alone यायला. If the quantity delta square f upon grad f bracket square is a function of f. Okay, alone. Now differentiate equation 1 with respect to x, y, z. So differentiate equation 1 with respect to x, y, and z. We get dou f by dou x. What is the dou f by x? 2x. Dou 2f by dou x square is equal to 2. Similarly, dou f by dou y. What is 2y? Okay, dou 2f by dou y square is equal to again 2. Dou f by dou z is equal to 2z. This dou 2f by dou z square is equal to 2. Okay, any doubt? Now, what is the delta square f is equal to dou 2f by dou x square plus dou 2f by dou y square plus dou 2f by dou z square, which is equal to value of this one is 2 plus 2 plus 2, which is equal to 6. This is the value of delta square f. Okay, now find gradient of f square. Now gradient of small f bracket square. this is equal to dou f by dou x in bracket square plus dou f by dou y bracket square plus dou f by dou z bracket square, which is equal to 2x bracket square plus 2y bracket square plus 2z bracket square, which is equal to 4x square plus 4y square plus 4 z square, which is equal to 4 into x square plus y square plus z square, which is equal to 4 into
R square.
r square. Okay, now look at this one. But what is the value of r square? R square is equal to small f of xyz. Okay, so this is equal to 4f. Okay, this is the value of gradient of f bracket square 4f. So therefore, delta square f divided by gradient of f square is equal to 6 upon 4f, which is equal to 3 upon 3f. Okay, now quantity of this one is the function of f alone. Okay, फक्त f च चाललेलं तुमच्या इथे. So this shows that x, y, z कुठेही नाही आला इथे. Okay, so this shows that the given one parameter family of surface form a family of equipotential surfaces. Okay, now we have to find the value of potential function. Now to find the general form of potential function. General form of potential function. Okay, general form काय म्हणतोय? We don't know the value of a and b. Okay, the integration constant मध्ये आपल्याला व्हॅल्यू माहिती नाही कोणाच्या, या a च्या आणि b च्या व्हॅल्यू माहित नाही. That's why we call that function is general form of potential function. Okay. Now, what is the value of psi? Psi is equal to integration into a into e raised to minus integration chi of f df. Okay, into df plus v, which is equal to integration of a into e raised to minus value of this one guy 3 by 2f df. Okay, into df plus b is equal to integration of a into काय येईल हा if खाली आहे ना, सॉरी 2 खाली येईल. e raised to minus 3 by 2 integration 1 upon f df. This is df plus into. Okay, now solve this one. Integration a raised to minus 3 by 2 log of f df plus b equal to integration a. Okay, आता इथे गेल्यानंतर ह्याच्या डोक्यावर येईल e raised to log x काय येईल x म्हणजे काय येईल हा f raised to minus 3 by 2. समजते ना कसं ते? e
Yes,
raised
sir.
to log f raised to minus 3 by 2 to df plus b. Now e raised to log x काय असतो x असतो. This is integration a into f raised to minus 3 by 2 into df plus b is equal to now a into integration of f raised to minus 3 by 2 df plus b. Okay, the has items which is equal to a into f raised to minus 3 by 2 plus 1 जो कह रहा माइनस यहाँ minus 1 by 2 plus b. Okay, so therefore psi is equal to minus 2 into a into f raised to minus 1 by 2 plus b. Okay, now therefore psi is equal to minus 2 into a. What is the value of f? r square ना, r square raised to minus 1 by 2 का ये r raised to minus 1 plus b. So therefore psi is equal to minus 2a upon r plus b. So this is the value of our potential function. Okay. Okay. Any doubt? So here
No,
we
sir.
showed that the surface x square plus y square plus z square is equal to r square, where r is greater than 0, forms a family of equipotential surface and the general form of potential function. Okay, example लेते तो just solve करो. Wait a minute. Solve this is for the homework. Show that the surface x square plus y square plus z square is equal to c into x raised to 2 by 3. Okay, can form an equipotential surface and find the general form of potential function. Okay, सॉल्व करने से प्रयत्न करा जल्द नहीं आया तो अपन उद्या हो गया. Okay, any doubt in this topic?
Okay, sir. No, sir.
Okay, wait a minute.
No, sir.